All right, let's talk about lightning. It is one of nature's most incredible shows, right? We've all seen it, we all feel like we get it, but for hundreds of years, a massive piece of the puzzle was just missing, and it left behind a fantastic mystery for scientists to unravel. Think about this for a second. At any given moment, as you're listening to this, there are about 45 lightning flashes happening somewhere on Earth, every single second. That adds up to something like 4 million flashes a day. It is a constant global light show. And yet, for as common as it is, the actual trigger, that exact split-second moment a bolt is born inside a cloud, that was a deep, deep mystery. I mean, we're talking all the way back to Benjamin Franklin. And this right here, this is the heart of the problem. The fundamental question that completely stumped physicists for decades. How in the world does that first spark happen when every measurement we took showed that it was basically impossible? This gets us to what scientists call the lightning initiation paradox. And it's a really cool contradiction that sits at the very center of this whole puzzle. Okay, so check this out, because this really lays out the problem perfectly. If you're in a lab and you want to make a spark jump through the air, you need a crazy strong electric field. But, and this is the big but, when we send instruments up into actual thunderclouds, the electric fields we measure are 5 to 10 times weaker than what should be required. The clouds just aren't charged enough. So what's going on? Well, to understand the trigger, we first have to see how the factory gets powered up. Before any strike can happen, a storm cloud has to build up an absolutely insane amount of electrical charge. You see, every thunderstorm has a life cycle. It starts with warm air rising, but the real action happens in what's called the mature stage. This is where you get these violent churning air currents, updrafts shooting up, downdrafts plummeting down, just mixing everything inside that cloud. This is prime time for lightning. Now, inside this churning chaos, an amazing sorting process starts. You have tiny little ice crystals getting shot upwards, and they smash into these heavier, soft hail pellets called gropal. Every time they collide, electrons get stripped off the little ice crystals and stick to the gropal. So what happens? The light, positively charged ice crystals keep getting carried way up to the top of the cloud, while the now heavy, negatively charged gropals sink toward the bottom. And this separation of charge has a huge effect. That massive negative charge at the bottom of the cloud actually pushes away the negative charges in the ground right below it. This leaves the surface of the Earth with a strong positive charge. You've just created a giant natural battery with millions of volts of potential difference, just sitting there, waiting for something to happen. All right, so the battery's charged. Let's break down the strike itself. Because what looks like one single instant flash to our eyes is really this incredibly complex step-by-step process that happens in just thousandths of a second. Okay, so first you have this invisible channel of negative charge, the stepped leader, that kind of feels its way down from the cloud in these short little bursts. As it gets close, the positive charge on the ground reaches up from tall things like trees and buildings in what are called upward streamers. The moment one of them connects, bam, the circuit is complete. And that triggers the main event, the return stroke. That's a brilliant surge of energy that rushes back up the channel to the cloud. That's the super bright flash we all see. And often that same channel gets reused for a few more strokes, which is what gives lightning that flickering look. And the power in that return stroke is just staggering. For a tiny fraction of a second, it heats the air in that narrow channel to over 50,000 degrees Fahrenheit. Let that sink in for a moment. The air inside a lightning bolt gets 5 times hotter than the surface of the sun. That explosive heating is exactly what creates the massive shockwave we hear as thunder. So we know how the charge builds up, and we know the mechanics of the strike itself. But this brings us all the way back to our central mystery, and the huge breakthrough that finally solved it. What is that secret ingredient? What's the outside push that lets lightning just ignore the normal rules of physics and ignite in a cloud that really shouldn't be able to make a spark at all? Incredibly, the answer came from space. A huge study led by Professor Victor Pascoe finally put all the pieces together, giving us the first complete explanation for how lightning really, truly begins. So here is the incredible chain reaction. First, a single high-energy cosmic ray from deep space zips into the storm cloud. It slams into an air molecule, creating a shower of super-fast electrons. These electrons then smash into other air molecules, producing a burst of X-rays. And this is the key. Those X-rays act like tiny energy bullets that blast loose a massive new flood of electrons. It's a runaway chain reaction that, in an instant, carves a conductive path through the air. And that's what lets lightning form, even in that weak electric field. A single, tiny particle from space ignites a gigantic bolt of lightning on Earth. Now, solving this fundamental mystery isn't just a cool science fact. It's about life, and it's about safety. The more we understand lightning, the better we can all protect ourselves from it. And just look at the progress. In the United States, the average number of lightning fatalities every year has dropped by more than half in just the last couple of decades. And that is not an accident. This success is a direct result of us understanding the science better, having better forecasting, and most importantly, doing a better job with public education and safety awareness. Knowing this stuff literally saves lives. So here are the key things to remember to stay safe. The simplest rule is still the best. When thunder roars, go indoors. A solid building or a car with a metal roof is your safest place. Stay away from windows and anything plugged into the wall. And this one is really important. A lightning victim does not carry an electrical charge. It is absolutely safe to touch them and to give CPR immediately. So after finally figuring out the trigger for lightning here on Earth, scientists are now looking up. And they're finding that our planet's electrical storms are really just the beginning. You know, lightning isn't just an Earth thing. We've seen superbolts on Jupiter that are way more powerful than anything we got. Saturn has storms with lightning 1,000,000 times more powerful than ours. And we might have just gotten the first hints of lightning on Mars, possibly created by giant dust storms. So, after nearly 300 years, we finally have the answer. A cosmic ray kicks off a chain reaction that creates a flash 5 times hotter than the sun. But of course, solving one mystery just opens the door to new ones. As we keep exploring our solar system, what other weird kinds of lightning are we going to find? And what incredible new secrets will they have to tell us?